Hi guys, today I'm going to show you my final year project that's supervised by Dr. Saman at RMIT University, and my project is about demonstrate the wind effect or the action of the wind on the high-rise building. So I got 2 semesters. For the semester 1, I create an ultimate tool that generate the shear force on the building and also the bending moment at the ground floor by different aspects of the wind region, wind speed, and parameter of the building, like what height and what width of the building. And the second semester, I'm doing the wind tunnel, as you guys can see in the background. And now I'm going to show you the component of the wind tunnel and also the result when I apply the smoke heating
Setting chamber where the smoke starts to flow in. The dimensions of the setting chamber itself is 90 centimeters by 90 centimeters. The chamber is made of individual black straws of 0.5 centimeter wide by 4 centimeter length. These straws, they make up a honeycomb structure that helps to straighten wind flow, and at the same time it also helps to reduce turbulence as the wind starts to flow in. However, the honeycomb structure by itself has limited effects on the reduction of wind. Hence, at the back it is covered by a linen mesh. This mesh works in tandem with the honeycomb structure of the setting chamber to help reduce wind turbulence more effectively. This is the contraction cone section of the wind tunnel. The cone itself is made of 4 sheets of plywood. The entrance has the dimensions of 90 centimeters by 90 centimeters, and the exit has the dimensions of 40 centimeters by 40 centimeters. The ideal ratio should be 6:1. However, this contraction cone has an error ratio of 5:1. The reason being that it didn't follow the ideal ratio was that the wind tunnel would have been too big and the setting chamber would require more cells to compensate. This would have taken more time, and I didn't have that much time due to time constraints. The cone itself has the function of accelerating the wind flow from the entrance to the exit while minimizing wind turbulent eddies. It also compresses the wind into a smaller area. This is the test section area of the wind tunnel. There are 2 plywood sheets which are painted black to allow easier observation from the smoke. Attached to them are 2 plexiglass sheets at the side and at the top. This would allow easier observations. At the top of the plexiglass, you can see that a cut has been made with a hinge attached. This would allow easier setup of the models. The length to width ratio of the test section area is 2:1, with the length being 80 centimeters and the width being 40 centimeters. The test section area is the section where models are placed for observations with wind. This area is where the wind flow is most constant. This is the motor of the wind tunnel. It's installed at the back of the diffuser itself. This motor produces suction effect by drawing the air in. A ceiling fan is used for the motor. This is the smoke machine. It is used to generate white smoke. The model is Vaporizer V1000. These are the 2 models that will be placed in the test section area of the wind tunnel. One is a rectangular block, while the other is a helical shaped model that serves as the basis of what was used for my high-rise and long-span project that is run by my professor, Dr. Saman of RMIT University. This model itself is a smaller scale version of the model that is used in my other project. These two models will demonstrate the degree of wind turbulence on the rectangular model and the irregular yet modernized building shapes. This is the wind sensor that is supposed to be used in the wind tunnel experiment. The wind sensor is connected to an Arduino device, which is then connected to the computer itself. The application that we use is also called Arduino, and it comes with its own coding and programming. However, due to the lack of programming itself, we do not actually able to see the wind speed effects or the values. The only values that it shows are the output values, which are insufficient. However, as you can see, when we blow onto the wind sensor increases and the data shows a spike in readings. And when we stop blowing, the readings then go down. However, these values are not accurate and do not actually represent the wind speed values. This, however, would serve as a good first step for the next generation of students to do further analysis on the effects of wind speed on high
So in conclusion, this project is used as the starting point for the incoming engineering student to use to continue analysis on the wind effect on the building by using my Ultimate tool as well as my wind tunnel. And this wind tunnel also a very good example for demo teaching for Almighty University. Thank you.